Hello guys and welcome back. So the sim is done and it took 24 minutes for 47 frames, and this is the result it's playing. I'm using 256 for the viewport capture so that we have more resolution, but there is a lot more and we're going to see that once this is done. So I'm pretty happy with how this turned out. I think the main criteria that I'm looking for is no mushroom clouds, no uniform noise, and a lot of details without having to go super resolution, and I have all of that. I also like the motion. I think the dissipation is working really well. I can see it here. You can see it. Anything that is not facing forward is not being affected at all by the density, by the dissipation. I think it's too strong, but I think you guys can tweak this to your desire. We have all kinds of control for this, and I'm gonna just wait for this to finish, maybe up to frame 42, and then we'll take a look at the high-res version, and then we're going to learn a few more tricks about how to create more interesting masks. And this is going to be talked about in week 4. Actually, this video is in between week 3 and week 4, but I'm gonna explain a few things now that hopefully will get you guys started and thinking about the process of what we're going to be doing next. Cool. So yeah, I'm super happy with this, and let's take a look at this at a higher resolution. Let's try 1024, and maybe this frame doesn't have, it's not the best, but I think to me being able to create this clustering effect, you know, with all these super fine details is the primary goal for all these tweaks. And then we have all kinds of methods and techniques that we can control the sim with. I see this part here escaped and went somewhere. This is totally normal, but it's slowing down our sim drastically. There is a clipping threshold that can actually trim the data, and it's always better to have, right now the density is 10 times multiplied. It's always better to have the actual density within the sim instead of having to multiply the weak density so that we can see them. And the reason for that is we can be more aggressive with the bounding box and actually tell it to cut or subtract or kill any low threshold density, because they're not very visible if we're not planning to multiply it 10 times, of course. Cool, let's pick a different frame. I still think that the noise is a little bit too aggressive here, but if once we zoom out, and let me check the resolution. Yeah, so this is mid-res at this frame, so definitely totally fine. And I think, yeah, we have a lot of details. As we start zooming in, you can see getting a lot of cool shapes and patterns. Trying to increase to see if there is more resolution here. Let me check something. I'm gonna untick this and hopefully that doesn't change. There is this limit here that sometimes it affects this, but it only works if this is unticked. So this overrides the other setting. Cool, so what I'm going to do now is run a few more analysis on this sim to see what kind of details we can get out or how we can create some more interesting masks. So I'm going to create a VDB convert. And convert this into a VDB. Cool. I'm also going to multiply the density so we don't have to work with this low volume and have to display it every time using the visualization node. So I'm going to simply use a volume wrangle and multiply the density by 10. And this is better for the analysis that we're going to do. So what I'm going to do now is use a VDB analysis, and what I'm interested in is computing the curvature of the density field. So instead of the gradient, we're going to compute the curvature, and this basically will give us back a mask that will be darker where there is cavities and brighter where there is concave shapes. And right now this is how it looks. This is the display. Let me turn this back on. But when we look at it like that, we don't really understand too much about it. So we have to display it properly within the volume. So I'm going to merge this with the original density, and let me put down a visibility node. I'd like to hide this because we don't really care about it. So now we have density, and let me rename this properly. So we're going to call it curvature. I'm going to use a visualization node, and I want to display that curvature. So here, I still have to multiply. I'm going to use the diffuse field. I'm going to set it to density, to curvature, and I'm going to set this to red and blue. Okay, so now we start to see that information. Let me increase the sampling so we can display it better. Cool. So you can see now we're capturing the cavities of the volume versus the concave shapes, and we can actually tweak the range of the curvature. Let's see if it doesn't have any negative values. So let's try 10 here, and try to capture basically the full range of the curvature, because the value can go between 0 to 100 or sometimes 1,000, depends on the type of volume and the shape. So I'm going to move this all the way here, and I'm trying to isolate the cracks of the sim where we have all the cavities and stuff. Cool. I think something like that. Let me lower this to 0.5. Okay, let's take a look here. So we want that guy there. Cool, I think this is working, but now everything feels there's a lot of noise. It doesn't, I don't see any big cracks or anything like that. So I'm gonna add a VDB smooth. And I'm actually going to smooth the original volume just a tiny bit. And voila, you can see now we have much more interesting cracks, and this is the kind of details I was looking for in these guys. Okay, let's lower this a bit. Cool, so now we have volume curvature, and let me change the red to black. And let me change this to white. Let's go even more aggressive. Let's tweak the range a bit. It's not affecting. Yeah, it is working. Try 10 here. Something like that. So now we have we've isolated the cracks of the sim. Now obviously we need much higher resolution to be able to capture all this, and maybe I can move to a different frame. That's crazy. Let's try something here. Cool. So now we have, you can see all the cracks here. Now this information we can use again to drive anything we want. For example, we can use this mask here to take the gradient. If I can open. So let's say we have some kind of shape, and we have the cracks of the sim like that, we can take these cracks, and let's say we have a surface like this. This is a gradient. We can inverse the gradient and push the data in where there is and multiply it by this. So basically, and push anything backward where we have cracks, and this will accumulate. This will add. This will enhances the cracks between the shapes. It can be a little bit dangerous, but I think we can create something interesting or add more details. We can also use it to drive a different kind of noise, for example. And this is all things that you guys can do. What I'm going to show you now is a small deviation of what we're going to be doing for week 4. I'm actually going to use these guys to create an interesting fire pattern, or just get the idea going of how we can sculpt our own temperature fields. Okay, so we did this. We know how we can take the curvature, analyze it, and isolate the cracks. So let's do the same thing in DOPS now. Actually, I'm going to do that in the next video. Thank you guys for watching, and see you in a bit.